Okay, so the final part of the problem is to find the angle theta that gives the minimum area of the trapezium. So the area of the trapezium, as we can see, is dependent on the value of the angle theta. If we have a theta of 0, we're going to end up with a square. And if we have a theta at 90 degrees, or equal to pi on 2 in radians, you can see that this line PT is going to be horizontal, and we will end up with an infinitely large area. But before we go any further, we found out from the last step that the area is given by 2 minus sine theta divided by 2 cos theta. And mathematically we can find maxima and minima by differentiating and finding the stationary points. So what we do is we set the differential of the area A with respect to theta, so dA to theta, we set that equal to 0. So, but what is dA to theta? Well, we here have a quotient rule problem where let's give the top part of the quotient here u, and the bottom part of the quotient here we'll call v. So the quotient rule goes vu prime minus u v prime on v squared is equal to the differentiation of u divided by v. So carrying out the operation, v remains, so we have 2 cos theta. U prime is, so 2 differentiated goes to 0 because it's a constant, so we're left with minus, and sine differentiates to cos, so we have minus cos theta, minus u, so the top part remains the same, so 2 minus sine theta, and looks like I'm running out of space, so I'll write it directly below. V prime is constant 2 remains, and cos differentiates to negative sine, so I'll put a negative here, sine theta, divided by v squared, so that becomes 2 cos theta squared. Okay, so tidying that up, we'll have negative 2 cos squared theta. I'll leave the negative out front, and I'll expand this minus 2 sine theta in, so we'll have minus 4 sine theta, and the minus theta times the negative 2 sine theta gives a positive 4 sine squared theta. Sorry, positive 2 sine squared theta. And the bottom becomes 4 cos squared theta. Okay, so carrying out this further, we'll have negative 2 cos squared theta plus 4 sine theta minus 2 sine squared theta all over 4 cos squared theta. And let's collect these two, so we got negative 2 outside of cos squared theta plus sine squared theta plus 4 sine theta all over 4 cos squared theta. And again, if we realize that this here is equal to 1, we will end up with -2 plus 4 sine theta over 4 cos squared theta. Alright, so that was quite tedious. What do we get from it? Well, dA d theta is equal to -2 plus 4 sine theta all over 4 cos squared theta, and we have to set that equal to 0. Just by observing here, this bottom term here cannot be equal to 0 because division by 0 is undefined. So that means a term cos theta cannot be equal to 0. So I'll say that implies cos theta cannot be equal to 0. So that means theta cannot be equal to pi on 2. And as I said before, if theta was equal to pi on 2, we would have an infinitely large area. So let's assume that this condition is true. If this is a non-zero term, then we can just say that 2 plus 4 sine theta is equal to 0. And let's solve for theta. So that it would imply that 4 sine theta is equal to 2 and sine theta is equal to 1/2, which means that theta is equal to, the inverse sine of 1/2 is equal to pi on 6. Or if you like it in degrees, it equals 30 degrees. Okay, so this is the only value that is a stationary point in the range from theta equals 0 to theta equals pi. Now, if it is the only stationary point, it can therefore mean it only has pretty much only has two possibilities, to be either a maximum or a minimum. And if we wanted to find the maximum or the minimum mathematically, we would have to take the second derivative of the area. We've got a nasty cos squared theta here, and it's going to make the differentiation quite tedious. So as a lazy mathematician, I'm not going to do it. I'm just going to test 2 points either side of this theta value. And if the 2 points come out to be larger, then we know that this is definitely a minimum point. But if the 2 points either side come out to be less, then it's a maximum point. So let's try that. A of pi on 6 is equal to 2 minus sine pi on 6 all over 2 cos pi on 6, which equals 2 minus 1/2 all over 2 times the square root of 3 divided by 2. So this is 2 minus 1/2 is 1.5. So fractionally that's 3 on 2 divided by, these 2's cancel out, so divided by root 3. So we have 3 divided by 2 times root 3. Now let's look at the case of pi of 0, which means we have a square. So 2 minus sine of 0 divided by 2 times cos of 0. That is equal to, so sine of 0 is 0, so that gives 2. And this gives, cos of 0 is 1, so that gives 2. So we end up with an area of 1. So is 1 greater than 3 divided by 2 times root 3? Well, numerically, 0.866. So yes, when theta equals 0, the area is greater than when the angle is at pi on 6. And at the beginning, we found out that the A of pi on 2 gives an infinitely large area. So that's another point that we could test. And of course, 0.866 is less than infinity. So therefore, the angle where the area of the trapezium is the minimum is at pi on 6 or 30 degrees. So that's the end of the video on problem solving with plane geometry. Thanks for watching, and I hope you've learned something.
If you are currently studying math, please feel free to subscribe to my channel for future videos that may help you on exams or assignments. And as always, please feel free to ask me any question by commenting on any of the videos that you've seen. Thanks for watching, and I hope you've learned something.